Okay, so question 4 can throw people off because as you read the problem, it's easy to connect some of the properties together that aren't connected. So if we read, let's read through the whole question first. It says, a mountain climber with a body temperature of 37 degrees inhales 486 milliliters of air that's at a temperature of -8 degrees. So we have this volume of air that's at this low temperature. And then it says, what volume in milliliters will the air occupy in the lungs if the pressure and the amount do not change? So what they're saying is we have air outside of the lungs. That's 486 milliliters. And it's at a temperature of -8 degrees Celsius. And I'm going to add the 273 here. So -8, I have to clear my calculator. -8 plus 273, and I get 265.15 Kelvin. And then I'm trying to find out what the volume is going to be when it's inside the lungs, which are at the body temperature of 37 degrees Celsius. So let's add 273 to that. And I'm adding, excuse me, I am adding the 273.15 because that's what your book tends to do. Usually when I do these problems, I just add the 273. So it's 310.15. I don't think it's a huge difference unless you're in a class where your instructor wants you to do it a specific way. Then I think it's just as easy to do it whatever way. All right, so this asks for volume and temperature. So this is Charles' law. And Charles' law is directly proportional. Boyle's law is the only one that is inversely proportional. And directly proportional means they will change in the same direction. So in this example, the temperature is increasing. I'm just going to write an up arrow for increasing. It's going up. So then what we expect for our volumes is we expect the volumes also to be greater. So we'll expect our answer to be bigger than 486. So let's plug it in. So 486 divided by 265 equals our volume that we're looking for divided by 310.15. So I need to have volume 2 right here by itself. So I'm going to multiply the 310 across to the other side. So it'll be 310 times the 486 divided by the 265. And in this case, you see that the Kelvin cancels. We're left with milliliters, which makes sense because we're looking for a volume. So 310 times 486 divided by 265. And I'm putting in the 0.15 on my calculator. And I get 568.48. So that's milliliters. So 3, I guess. So just 568 milliliters, which makes sense. We thought the volume would increase as we increase the temperature.